Hello everyone, welcome to my channel on data analytics. I am your host Professor Rage Udaikiran. In this video, we are going to learn about packages in Java. The outline of this video is as follows. First, we will learn what is a package. Next, we talk about how to create those packages and use them. Finally, we will do a classwork in which we will design an application called calculator. Coming to the package, we use a story to explain the packages, their creation and usage. In the previous class on encapsulation, we have looked at this example where Didi wants to create a calculator using encapsulation. This class is the continuation of that video. So here, Didi, following the encapsulation techniques, created a calculator using the class files sum, difference, multiplication, and division. Now, she wants to sell those class files to the customers. In order to sell those files, it is important to create a package. Since Didi is not familiar about packages, she is asking what is it. So a package is basically a group of related class files. So if the class files particular to a topic, we store them as a single package. But the thing is, it is difficult to understand a package. So a easiest way is, please keep in mind that a package is a special directory or folder. Okay. Why is it special? Let us look at it. So if you call a package basically as a directory, then one can simply create a directory using the command, let us say, make dir calculator, and then they can simply move their Java files into the calculator folder. Okay. Simply pushing your Java files into that class calculator folder is not enough because it will create an error. Since the package represents a special folder, we have to follow some rules. So what are those rules? Let us look now. So now the Didi is asking about how to create the packages. So before creating the packages, we should keep in mind that there are two types of packages. One is the built-in package, that is the packages that come as a part of JDK, that is Java Development Toolkit. Next, we have user-defined packages where we can develop our own packages. In this video, we are going to look at user-defined packages. However, before going to talk about these user-defined packages, let us learn how the packages looks like. So at the top, we have the packages hierarchy where we have two types, built-in packages and the user-defined packages. If we look at the built-in packages, the topmost is the Java. Okay, so this is the Java package. Under this package, we have several sub-packages. For example, lang, util, awt, IO, and so on. There are several sub-packages. In each sub-package, we can have sub-packages or class files. So in lag sub-package, we have a system class, string class. Similarly, in util sub-package, we have array list, map class, and so on. Similarly, at AWT, we will have button class, radio button, so on and so forth. You will learn AWT in Java 2 course, basically. So always keep in mind, these built-in packages, we cannot change it. They come as a part of JDE. We can only work in the user-defined packages. Now let us do step by step how to create a directory. Step 1. First, create a directory for the package. So here you can see Didi is creating a directory in Linux using mkdir command, mkdir and the calculator name. Once you create this directory, next, in every Java program, the first line must contain the keyword package and the package name. For example, if you look at the program sum.java, okay, generally we write like this, public class sum. Instead, we should mention the word package calculator. So this word should appear above the class file. Similarly, if we have another class called diff.java, above the public class file, you have to mention the package name. So similarly, we have to do it. Once we specify this line, now we can move the Java files into the package directory. Okay, so you can see here using the move command, we are moving all the Java source code into the folder called calculator. Okay, if you are creating the files within this calculator folder, you don't have to execute this move command. Once you have done it, finally what you have to do is very simple. You have to execute the javac command by specifying the class path, package, and you can use start.java. So once you execute it, all the Java files in this package or sub package will be compiled. Okay, you can either use start.java or you can specify individual file names also, sum.java, so on, to compile. So here, since we have kept all files in the calculator folder, we are executing the command javac minus cp. Cp means class path, that is the current directory, followed by calculator slash start.java. So this way we execute. Sometimes, okay, we can compile the code and sometimes you may get the errors. The reason you get the errors is that you are calling third-party library files. If you are calling the third-party library files, then you have to make a slight change in your command. The slight change is for the class path, okay, you have to specify the location of the Java jar files. For example, you have to say that javac minus cp or javac cp. You have to specify the location of the jar file. Okay, if you have a single jar file, you can mention the location of the single jar file. Please try to specify it from the root directory. And if you have multiple jar files, you mention these multiple jar files by concatenating with the semicolon. If you execute like this, then you will not face any problem. Once you execute this command, you are creating your package. This way, your app is ready. This app, you can now give it to your customers and ask them to use it. But the problem the customers face is how to use your package. Okay, so he is asking about how to use the package, and DD do not know how to use it. So now we will see how to use the package. To use any package, we have to use the word import the package name. So this command will enable us to import the Java programs. Let us see how to do it. If we want to import the class sum in the calculator, we have to use the word import calculator.sum. This way, we will import the calculator. Once we import it, we can use the any class file. Let us say public class call usage, and you can create the object. If we do not use this import statement, and when you try to create an object using sum, the compiler do not know where this program is, and thus it will create an error. So that is how you have to import. Please note that this is how you will import a single class file. If you want to import multiple class files in a package, please use the wild character star. For example, you can simply say import calculator dot star. When you use this wild character, what the compiler will do is it will import all the Java class files that exist in the project or package called calculator. Once we do it, we can simply create the objects for the class files. For example, we can create some object small sum for the class, so on and so forth, and we can call them. So this way, we can create the objects for the packages. Before we continue further, let us briefly understand or refresh how the encapsulation works. We have already discussed that there are 4 types of modifiers: public modifier, protected modifier, no modifier, and private. Similarly, we have 4 types of Java files. One is a basic class file. Next one is a package. Next, we have subclass. And finally, we have world, means other classes. The security, if you see, if you define any class as a public, everyone can access that public. Okay, even if you define some variable as a public, any method as public, those classes, variables, and methods are available for everyone. If you define a class, a method, a variable as protected, then they are only visible to this class, package, and subclass. It cannot be visible to outside programs. And if you do not specify any modifier, then the class, the functions, and the variables are only accessible by that class and the class files in that package. Please keep in mind this visibility part. Next, if you define a class, a function, a variable as private, then those components are only visible within that class. It is not visible to any other Java program. Here is the example of it. Assume we have two packages, package 1 and package 2. In the package 1, we have a class file called alpha Java, and we have another class file called beta. In class 2, we have a program called alpha sub, which is a subclass of alpha. Next, we have another program called gamma. Now, please understand here, alpha is a basic class, beta is a basic class, alpha sub is a basic class, gamma is also a basic class. But alpha and beta, these basic classes are belong to a single package, whereas alpha sub and gamma, they belong to another package. More importantly, even though alpha sub belongs to a package, a different package, that is package 2, it extends the alpha class. That means alpha sub is a child of alpha. Now we are keeping the things here. So alpha, beta. So beta here represents the package. Okay. Next, we have alpha sub, which extends alpha. Next, we have gamma, which is completely a different program. So for gamma, alpha is a outside world. So this everything is based on gamma. Now, if I specify any variable or method in alpha as public, they are available for alpha, beta, subclass, that is alpha sub, and gamma. Because public means everybody can access everything. Now, in alpha class is defined using protected. Okay, if the class name, if the class, function or variables are defined using protected, now those components are accessible for beta. Okay, beta can see those components. Similarly, alpha, which is the child of alpha sub, which is the child of alpha, can also see those components, that is variables, methods. The gamma, which is the world, cannot see those components. Please keep that in mind. Now, if I have variables, methods, and even the class do not have any modifier, then those components are only visible to either to alpha itself or to beta, which belongs to the package. And if you specify the keyword private, then those components are only visible to alpha class. None of them will be visible to beta. So this is how the encapsulation works. So everything, every Java file is a base class. But if you put them in the package, they form a family. Next, you have a children by using the subclass. So private is within the class. No modifier means package. Protected will come for the subclass and public for the world. Private, no modifier, protected, and public. So this is how the encapsulation works. Finally, let us look at the key summary. The first point, to create a package of a particular type, you have to put the statement package as the first statement in your source file. The first line of your Java file should contain the word package. To use a public type that is in a different package, we have three choices. One is use the fully qualified name, or use the import the type, or import the entire package. Third one, the path names for a package source and class files mirror the name of the package. That is, if I compile the source file using Javac and the class part, we will create those class files only. The class files and the source files will have same extension. Finally, you have to use the class path for your Java compiler to identify the class path. If you do not specify the class path, your compilation may give error. So these are the key takeaways. Now, let us do the class work. The task is as follows. So in the classwork, we are going to design a calculator. The calculator has two functions. First one is it has to do basic mathematics, that is sum, difference, multiplication, division, and modulo division. Next, it has to do some trigonometry also, that is sine angle, cos angle, and tan angle. Only for these three we have to create. So this is the class application. So let us see how we do it step by step. Step 1 is very simple. We have to define the package hierarchy. To define the package hierarchy, we generally use the domain or the license type. For example, you can use the word com to represent that my package is meant for commerce purposes, that is to earn revenue. Or you can use the word org to represent the organization. Net for network. EDU means your software is meant for education purposes. If you want to say that your software is open source, you can use the term FLOSS. FLOSS is the term which we use for representing open source software. Similarly, if you want to say that your software is follows GNU license, you can specify GNU license. If you want to know more information on how to specify the domains, please check the link that has been provided here. Okay. So this is the step, and here we will try to recreate this execution area. So first, we have creating the hierarchy called org. Okay. Because since we all belong to the organization, let us use org. If you want to develop a commercial one, please use the word com. After defining the first level, the second level, we will define the institute or company. Since ours is an organization, UISU, that is University of ISU. This is our second level. The third step is the title. So the title of our application is calculator. This is the third hierarchy. If you want, you can remove these two steps because they are optional. But this third step is important. You cannot skip this third step. So please keep that in mind. In Python, we generally start from the third step. But in Java, we generally start from the org domain name followed by the company or institution name and then the project. Once you define it, now you have to give the proper hierarchical structure. So we have this problem definition. Our calculator should support basic mathematical calculations and trigonometry. So please pause the video for 5 minutes. Look at this problem definition and create your own hierarchy. Now I assume that all of you have created your hierarchy. It looks as follows. Since we have two tasks, I am creating two sub packages which are basic to represent basic mathematical calculations and another sub package called trigonometry. Once we define it, we try to create classes. Before create classes, please keep in mind that the structure need not be balanced. Here it is balanced. If I create some more levels, it becomes unbalanced. But right now, this is a balanced, but your hierarchy need not be balanced. Now create the class files. Very simple. So under basic, I have the class files sum, difference, multiplication, division, and modulo division. Similarly, for the trigonometry, we have sine, cos, and tan. So this way, we have created the conceptual diagram. Before we go into the development of this package, the most important thing is if you are building it as a team, especially, you have to define the abstract classes and interfaces. This will ensure that you are using the consistent terminology across your class files. So here, I am creating the abstract file called ABS for basic and ABS for trigonometry. Please observe that I am using different colors to represent these abstract classes. The reason is, although the file names remain the same, the code within these abstract files can be different. If you are familiar with Linux in the paper, try to create the directories that are representing this hierarchy. You are given 2 minutes to create the directories. Please pause this video. Please check your answer with the mentioned here. So now for those who have done it wrong, let me try to explain what we are trying to do. The first or the top level in our hierarchy is org. So first I am creating a directory called org using mkdir command. Next, I am entering into this org directory using the command cd, that is change directory to org. Next, I am creating another subdirectory called uiso. Okay, here I am creating the directory and then I am entering into this subdirectory and creating another directory called calculate. Next, I am entering into this calculator directory and creating two sub packages which are basic and trigonometry. So this way, after designing, we create the directories in the step 2. Once we create these directories, next, the third step is we have to create the abstract class files. The task 1 is please create the abstract file for basic subpackage. You are given 5 minutes time. Please pause this video. I hope you have created your abstract class file. Let us check your class file with the answer. Now let us look at the answer. From the calculator folder, we enter into the folder basic and create the file abs.java. In this file, we have to first mention the package hierarchy, that is package org.university of Aizu dot calculator dot basic, means this is the location where we are going to write the abs.java program. So please remember, after the package you have to put semicolon. After writing this package word, you have to create the abstract class. In this class, since this is the calculator, we have two variables, var1 and var2. So, and then for this class, we are writing constructors. Here I have written two constructors where if the input is double A and double B, we can simply assign them to variable 1 and variable 2. If they are integers, we can do the casting. Similarly, if the variables are strings and so on, we can create multiple constructors. Once we have these constructors, we have an abstract function called getValue with no code. So what this abstract function will do is, if anyone is extending this abstract file, they must write the code for this function. This is the reason why we are maintaining this abstract file. So this is the code. Please observe this and write the code for the trigonometry. That is, write the abstract class file for the trigonometry. We will give you 5 minutes time. Please pause this video. I assume that all of you have created the abstract class file for trigonometry. Let us look at the answer. Since I was in the base folder using the command cd / trigonometry, I moved into the trigonometry folder. In this folder, I am creating another abstract class file called abs.java. So here in this Java program, please check the first line. Here I am going to mention package org.university of Aizu calculator and the subpackage is trigonometry. Please keep in mind that if you use the package basic here, you will get compilation error because you are not in the basic folder, but you are in the trigonometry folder. So you have to mention the trigonometry folder here and not the base. And then do not forget to include semicolon at the end. In trigonometry, we have only one parameter, that is angle or degree. So what I am going to do is, I am going to create a public class file, and then I have only one parameter, degree 1, and using the constructors, I am going to assign the value to the degree. Similarly, I have a function get value, which the user has to write the content of this function. So this is how we create the package. Once we create the abstract files for each sub package, we can now ask your team members to import the sub package and write the programs. So this is your step 4. Please write the sum file using the abstract file given previously. You are given 3 minutes of time. I hope all of you have written the code for sum file. Otherwise, let us see at it. So now we are entering into the basic sub package and creating the program sum.java. In this program, the first line is package arg.university of Aizu calculator basic. Please keep in mind that the hierarchy should match here. If you miss any word, you will get the compilation error. Next, we are using the word public class sum extends abstract. So we are going to follow the abstract file, and from this abstract, once we do it, we are creating the constructor and passing those values. And then we are also writing the code for the get value. Here we are simply going to say this dot var1 plus this dot var2. This way, using super, we pass the values to variables and print the value here. Similarly, we can write the code for other basic mathematical functions such as subtraction, multiplication, division, and modulo division. Now, try to write the Java program for the sine file in the trigonometry. You are given 3 minutes of time. I hope all of you have written the program for sine class. Please check your answer with the what I am going to show. So from base folder, I am going back to trigonometry and creating the file sine.java. In this program, the first line is package arg.university of Aizu calculator trigonometry. So in this package, I am going to import the mathematics library to perform the sine function. So here I am going to create the file public class sine extends abstract class, taking the parameter and passing it. And finally, I have the get value, which will return math.sine this.var. So this will complete the execution. So similarly, you have to write the program for cosine and tan. Once you have written all of these programs, at the final step, you have to compile the package and complete it. So the way to compile is use javac, mention the entire directory here, put start.java. This way, all the Java files in BASIC will be compiled. Next, you compile all the Java files in the trigonometry using the JavaC class. You can specify -d parameter to store the class files at the current location. This way, we can compile and execute all the programs. That's all. Thank you very much for listening to the video.